Hi guys, thank you for keeping up with PWJ. We are finally at the stage where we can do our I/O, file input output. We're gonna read a file from our local file system and then write the outputs of the computations or the manipulations of that file into an output file within our file system as well. So first things first, where from is the file? We got the file from an online free repository. You can also access it. We'll provide this link in the description of this video below. Let's press enter here so that you can see how the file looks like. It's a pretty large file, so it might take time to even display. So look at here, it's still trying to load the file. It's large. I'm going to stop it. You're going to download as well. I already have it in my file system. So let's go to VS Code now and try to understand how can we read a file such as this. I have saved the file in my file system as accesslog.txt. You can give it a new name. Whatever name you give it, the contents remain the same, and the mechanism or the methods of accessing it is still the same. So in essence, we have got two methods of reading or accessing files in Python. We've got a traditional mode which allows you to read a file, like open the file, and then do whatever you want to do, processing with the file, and then you close it. Then we've got a second way using context to read the file. So the file is accessible within the program so long as it's contextually applicable. So the context basically uses scope, so that if your program or your file is deep in the scope or is nested deep into your for loops or your if statements, then you try to access it at an outer scope, you may not be able to access it. So immediately that scope ceases to exist within the program, then Python is able to automatically dispose the file for you. In the first method, if you fail to close or forget to even close the file, Python may not know that you won't need the file, so that may constitute to a disadvantage with regards to the performance of your program. It may result to a memory leak. You don't want that to happen in your programs. So let's start and check how the traditional mode works. So I'll say number one, traditional. So you do it like so. I'll say F, assign, open. So you give it the file name here. I've stored my file in the same directory as the program I'm writing right now. So there is no need to put forward slashes to access a lower level or deeply nested directory. So I'll just say access underscore log dot txt. Then I'll say comma, then give it the string R. So this side here, call this part the file access handler. So that's the name of the file in the file system. So this one here is the access method. If you want to read the file, you use R for reading. Then for writing, we're gonna use W. That will be for writing. Then for appending to the file, because sometimes you may not like to overwrite what is in the file, so we add to whatever is there. Use A. That's for appending. It should be 1p. Yes. So those are the file access methods. So now F points to the file in the file system. I can now read the file. So I can say line within f, assign f dot read line. I'm just reading one line within the f pointer here. So now here I'm done executing or manipulating the file or accessing it. I have to say f dot close. That's a traditional way of reading files. Let's see if it works. Are we able to print the line there? I'll say print line. We should be able to get at least one line from the file. Let's run. Let's try to execute this. It should be file2.python, files2.py. Yes, that's the first line printed there. Rather, you should be careful though when you download the initial file from the online repository, because the first line was a blank. You may have to delete that blank. Then the first line will be this one as shown in the screen. So you could see that now here you manually open the file and you are manually closing it. If you forget to do this, Python may not even warn you. The program still works, but it may have a memory leak as you go down with your programming. Let me comment that one off. Let's go to method number 2. Method number 2 for reading files is the context way. We're gonna use the with context. So how do we do it? We're going to say with open, almost same as before, open, then we say access log.txt, access log.txt. Then we also give it the mode. We want just to read it. Then we give it a handle as well, so still we can give it the F just like before. Then within that context, then we can manipulate our file. Let's copy the previous steps as we had before. Copy, and I'll paste here. Let's try to run the file and see if that works. Okay, it's an indentation error. This should be in one line. Save. Let me run this. Yes, of course you can see the first line being printed there. So that works. So, however, let's try to still read the file outside the scope of the existence of F. So we'll read the next line here. Outside the scope, we'll copy this and reduce the indent. We'll try to do this. Line assign F dot read line. That's like we're trying to read the second line because the first pointer of line checked the first line, and then the pointer went to the second line. So the second line now is the one we're trying to read here. But then we are already outside the scope of the definition of F. So let's see what's going to happen. See, we've got an IO operation. The file is already closed. But look, we didn't even explicitly close the file here. Python decided to close it for us because we are outside the context of the definition of F. So here we have no access to the file. This is the guaranteed way, or this is, even though the first works as well, but this way is the one we're gonna use in this application as we continue with our file analysis. So now let's continue. Assume in this file we want to count the number of IP addresses that tried to access our server. So we will check the IP addresses, access the IP addresses, and then when we get to it, we'll have to count one by one how many times it tried to access our server. It's as simple as that. So we'll access the file and then read a line at a time, and then once we're done with that, we'd like to define a dictionary. In this dictionary, that's where we want to put the IP addresses and the number of times that IP address tried to access our server. So I say IP counts, assign a dictionary. Remember, we define a dictionary like that. There are other alternative methods, but for now we may not use that one, so let's stick to this one. So now we'll say, while we have access to lines with contents from the file, we want to print, or we want to process the file. So let's write a while loop. That's how we write it. So say while we have got contents, that is, while line is not equals to an empty string, or while there is something in line, do the following. So we're going to split the line, the current line we have. So we'll say line list assign line dot split. Yes. Then you realize that now we have split the lines. If we don't specify the splitter here, it's immediately implied that we are splitting according to blanks, not commas and not dashes. So since the IP address appears first, so we'll say IP assign line list 0, because this one is going to give us a list, and then we'll take the first element, we put it in IP address, and then we'd like to push the IP address into our dictionary so long as it wasn't added. If it has been added already, we'd like to just count the number of times it's been added. Don't add. So that's how we do it. Let's try it. So we'll say if IP in, so I'll check my dictionary here. If IP not in, because we don't want to count if it's not in. If IP not in, IP counts. So then now we are going to say IP counts IP assign 1. We are going to initialize that. So we'll say IP counts at IP. So we're initializing the key to 1. Else we want to increment the contents at IP. So I can just copy this, paste here. So we increment the contents at IP plus equals to can work. So let's go down. So now we've got the logic that's going to count the number of occurrences of IP addresses in our file. So all we need to do is to advance the file reader pointer, this one, within the while loop so that we can execute through the whole file. Remember, the file is big. We have to read line by line. So you can't use the method read lines. If you do, you might suffer memory leaks and you may have to change even the way you are manipulating the contents of the file. So let us save now here, and then maybe outside here we may like to just print the contents of IP counts. So let's say print to see what has happened. IP counts so far. So now let's try to save and run the file and see if everything is coming up fine. Yes, here is the output. We can see that the IP address 75.55.248.248 accessed the server once, while 157.55.139, this one, accessed 3 times. Others, like this one, accessed the server 14 times. Great. At least we're able to find some useful information here. So this is a dictionary. In the previous session, we learned how to print the values of a dictionary. So let's try to do like so. Print the contents of this dictionary so that it's not a list. Maybe the first 10. Let's say for key, comma, value in IP counts dot items. Remember, items. So we want to print the contents. So we can't say that. Let's just say key, comma, value. So let's put probably a threshold to, let's define threshold so that we don't print all these values here. It's even difficult to some extent to read this. Let's say we want only values or only IPs which accessed our server at least 800 times, because that's a huge file. We should have such. So let's say threshold assign 800. So copy that threshold. Then here we'll say if value, that is the count of IP address, value is greater or equals to 800 or is greater or equals to threshold, we want to print that. Save. Then let's try to print the contents of this file, or the contents of the list which accessed our server 800 or more times.
The Bluetooth device is ready to.
Okay, now, sorry for the disturbance, guys. Now we can see that we have got at least close to 20 IP addresses which accessed our server more than more than 800 times or so. So now let's increase the threshold probably so that we could have 10 or so values printed, manageable values. Let's save that. Let's run. That's too low. Let's revert to 800. 800 should be fine. Yeah. So now that we have got these values here, about 20 values, not too high, not too low, let's try to write these values here into a file, an output file. We will use the same mechanism here to write to a file. We'll also store this file in our current directory, so we don't have to put the access methods like this, deep nesting. So we'll say with open access log.txt, but access log is where we read our IP addresses. So now we want to write them to some other file. So let's say this is top. We'll say it's top access.txt. Now let's say we decide to use a CSV, because it's popularly used, this CSV file format. Let's now use W, because remember initially we had said here on top here, we said to write a file we use W when we started. Oh, okay, I happened to delete that part, but to write to a file you have to use W. So now we're defining a new F. This F is not the same as this F, because this F was immediately destroyed at the end of the context here. So now here I'll say F dot write. So I'll just take this condition I have here. The whole logic applies, because I want to write only the top IP address, top accessing IP addresses. So now I'll say, instead of printing, I'll say f dot write. F dot write. Save. So I'll write the key and a value. Save. Let's see if that works. Let's run. There is an indentation error. Let me work on that. Okay, this if statement should be indented. Save. Let's run again. There is also a problem, or the write method takes only one argument. Two have been given. We can convert this key to a string and then concatenate both values to one string. So this value here, the integer, is converted to a string. Then this key is already a string, so we can leave it like that. Let's join this by a comma, because we're writing a CSV. Then let's put pluses to make it one string. Let's try to write again. Voila, everything is good. The file should have been written to the file system. Let's see if indeed the file has been written to the file system. Let's check our file system. Let me open it quickly. Yes, as you can see, guys, this is the output. The file has been written to the file system. So from this output we can be able to plot or do graphical analysis based on this. But for an exercise, you can even put dates on the dictionaries so that you can see when exactly did the user access the server we have here, because you may like to know the dangerous or the vulnerable times for your server, because some of those accesses may be malicious while others are authentic. You may also like to analyze the file with regards to the IP addresses which access it frequently. What resource exactly are they trying to check? So then you can serve them accordingly. And you can also check, because the file has access status 200, 400, 403 and the like. You can then see if your clients have been helped, and then you can call them and try to assist. These analysis can be done on a monthly basis. Thank you guys for following the session till this far. Thank you. I hope you benefited. I would like to urge you to subscribe and like the video if you enjoyed it, and please invite friends to also subscribe to the channel, because I hope to drop even more useful content here. Thank you so much. Enjoy your day.